Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to talk about my current project of coding the combat system for a viewer's game. In particular, I'd like to talk about an experience that I had, which you are also likely to have in your own projects, which can be quite frustrating, but which is ultimately for the best. And what I'm talking about is the situation where you think about a particular part of your project and what you've done, and you realize that there's some error with it or problem with it, or at least some way in which you want it to be better. It doesn't quite do what you want. And you end up, usually you'll end up with asking, well, what's a small change I can make, or what's a small addition I can make to the code that I've already got? And you may find a solution, but sometimes you'll end up going, well, none of these small changes work. I really have to kind of start again to an extent. I have to sort of get rid of all of the last, couple of days' work that I've done and put in a new system. And that can be quite annoying because you put in that work into the old system. Obviously, you thought it was good because you saved it, and probably you were quite sort of proud of what you've done, and or at least relieved that you'd managed to solve, whatever you thought you were solving. And now you've suddenly decided, well, actually, I'm just going to scrap all that. All of that was for nothing. So you probably end up, as I do, feeling quite sort of annoyed with yourself. But I don't think that is completely justified, a feeling, because first of all, you might not have thought of that solution until you'd done the work that you have done, right? In my case, I don't know if I would have thought of the solution that I eventually thought of unless I'd done the work that I'd already done. So that work, even though it gets sort of deleted, it's not necessarily wasted. It might well be that you needed to sort of think that problem through before you got to the final answer. Even if the final answer is sort of quite simple, that doesn't mean that it's easy to think of. Often a complicated solution is the first thing you think of, and you'll do the complicated solution and you might go along and eventually realize, well, actually, hang on, I could get rid of all this and do a simple thing. And it feels like you're kind of an idiot. Well, why didn't I think of this? Why didn't I think of the simple thing first? Because we sort of, I guess we tend to think that we should think of the simple thing first because that's easier to think of, and the complicated thing should be harder to think of. But that's not really true. The simple solution is not the obvious solution. So even though I have felt frustration over this, I guess I sort of rationally realised that maybe I shouldn't, and that maybe the work that I feel like I've wasted, I haven't really wasted. So that's all very general. Let's be more specific. Well, what we've been working on, if you've been following this series, is a system for setting up where the enemies are at the start of the combat. We initially had a very simple system. They're all at distance 5, and then they might go towards the player character and any companions they might have, or they might sometimes retreat. The companions might move towards them, and the player character might move towards them or away from them. But they always start at that set distance. Well, that didn't work for what the viewer whose game this is going to be wanted, because they wanted a limit of 3 hovering enemies and 3 non-hovering enemies in each distance band, mainly because of the way the visual display was going to work. If there were more than 3, it would be quite difficult to show how many there were at a given distance. So we put in a limit of 3. Well, that created another problem, which was the way that the code worked. We tended to have all of the enemies of one type in one block, and then all of the enemies of another type in front of them, and then perhaps if there were 3 different types of enemies in the one combat, we'd have yet another type in front of them, and they would always be in that order just because of how the code worked. And in the last video, I thought I'd solved that because I'd worked out a way to swap, to sort of randomly swap the positions of enemies as they were placed, and then that would tend to mix them up. And so I thought that as of the previous video, I thought that I'd solved this particular problem and we could move on to something else. I realized today that I had not thought about a very specific situation, which is where we make a swap, and the swap is between a hovering enemy and a non-hovering enemy, and that breaks the limit of how many we can have. So an example of that is, let's say we have 3 hovering enemies in a given area, and that's the maximum we can have. We have 3 hovering enemies and 1 non-hovering enemy, and then we swap the non-hovering enemy with a hovering enemy. Well, now there's 4 hovering enemies in that area, and the code doesn't check for that possibility. That shouldn't happen. That breaks the limit. And in trying to think about how I could fix that, I did what most people will do, which is thought, okay, what's some extra lines I can bolt onto this? I could limit the swaps to hovering enemies. Okay, but then that still means that the non-hovering enemies would all be in the one place. I could do the swaps, and then afterwards I could run a check and fix everything. And eventually I realized that the best thing to do was probably to set up a completely new system in which we keep track of how many of each type of enemy there is in a given range band, and we place them in random range bands, only stopping once we've reached a limit. In other words, we put hovering enemies. We might put 1 in band 4, 1 in band 1, 1 in band 3, another in band 3, 1 in band 2, and we just keep doing this randomly until we either ran out of ones to place, or if we had 3 in a given range band, well, if we picked that number again, we just ignore it and choose one that didn't have the limit. And of course, in order to do that, we would need to have some array that keeps track of how many of each enemy we have in a given range band at the moment. And that's quite useful because when the enemies move, we're going to want to make sure that they don't move in a way that breaks the limits. And if we've already got a variable keeping track of how many of each type there is at each distance, that means we don't have to work that out from scratch. So first of all, let me just show you what the new system looks like, and then I'll run you through it. So click on that one. We've got a single enemy. In the old system, and then in the revision that I made as of last video, this enemy would always be at distance 5. But in the system that we have now, they could be in any of the distances from 1 to 5. They might be at 5, but they'll probably be somewhere else. So let's have a look at where they go. And indeed, in this case, they are at distance 4. So this makes for slightly more variety. I mean, distance 5 and distance 4 isn't very different, but sometimes they might be at distance 1. Sometimes they might be, somewhere else. And so that just adds a slight bit of variety to the combats. Let's try another one. Oh, we have another enemy, one enemy. This time they're at distance 3. We'll try one more, see if we get a more numerous. Oh no, we got one again. Distance 1, so that's sort of quite different because they're in attack range straight away. I'm going to try and get one with sort of lots of enemies. Oh goodness, sorry. I seem to be just rolling. There we go. So we got 6. So in the previous setup, we'd have 3 of them at distance 5 and 3 of them at distance 4. In this case, as it is now, they should be more spread out. So let's have a look. And yes, we can see that they're at 4, 3, 2, and 1, and there's no one. There happens to not be any at distance 5. So again, that makes for a slightly different setup, and therefore hopefully slightly more interesting combats. We can also see that they're observing the limit of 3 still, and in fact, no matter how many combats we set up and no matter how many enemies there are, up to the limit of 15, we'll never have more than 3 hovering and more than 3 non-hovering. Even with 14, they're still going to obey that limit. They're still 3, 3, 3, 3, and 2. In this case, they are set up the way that they would have been in the old system, but they could just as easily have had 2 at distance 2 and 3 at distance 1, for example, instead. So it's slightly more varied, but it still observes the rule of not having more than 3. So let's have a look at how it works. So I'll just zoom in a little. There we go. Okay, so as I said, we need a variable to keep track of where the enemies are, and particularly we need to distinguish hovering and non-hovering enemies, and we need to keep track of which range band, or how many is in each range band. And we do this with 2 new variables, which are arrays, enemy underscore hovering and enemy underscore ground. And as the note says, as you probably guessed, enemy hovering is the hovering enemies, enemy ground is the enemies on the ground, or the non-hovering enemies. And we have a for loop which gives them all and gives every slot an initial value of 0. In this case, I've gone from -10 to 10. That's probably overkill. They're probably not going to be, we're not going to need all of the range bands from -10 to 10, but once I deal with the something that I've talked about but haven't done any coding on yet, which is the viewer whose game this is going to be wants some of the wants the battlefields to be limited and wants some of them to be such that you can't run away, some of them that when you do run away, that's the end of the combat. Once we do that, we'll have a clearer idea of exactly what range bands we're going to need. So, but I just thought we'll just sort of overkill it. Doesn't matter if we set up too many, we can come back and restrict it later. So we've got these 2 arrays, and what happens that's new is all in setup combat and in this new passage called choose range band. So here we go. In fact, most of it is in choose range band, as you'll see. So here we are in setup combat. We're setting up the some of the details of which combat we're doing and the player characters, etc. But here we're going through setting up all of the different enemies. And we had, you'll remember last video, we had quite a lot of code here when we were choosing the distance. And we also had some code up here for how many we'd put in a given range band and which range band we were currently placing them in. Well, we're not doing it that way now. We're doing it randomly, so we don't need any of those. We had 4 of them because we needed those 2 bits of information for hovering enemies, and then we needed those 2 bits of information for non-hovering enemies. So we got rid of all that. Instead, we just include choose range band, and then we set enemy W3, which is the what distance enemy number W is from the player character. We set that equal to Z2, which is a value that we're going to generate in this new passage. So let's have a look at that. Here's how we do it. We set Z2 equals a random number from 1 to 5. Then we have an if. If enemy W4 is equal to the text capital Y. W4, enemy W4 keeps track of whether enemy number 4 is hovering or non-hovering, and they will have a capital Y or a capital N. So if they are hovering, we do this, and if they're not, we do this. These 2 bits of code are basically the same sort of structure, but they use different variables because we deal with hovering and non-hovering enemies separately. So let's look at this one. Let's say they're hovering. Well, we look at enemy underscore hovering Z2, which is how many hovering enemies are at distance Z2 from the player character. And if that number equals $stack, which is the limit, it's currently 3, set to 3 and initialized, but we could easily set it to something else. If it currently equals 3, well, we can't put another one in that range band because that would break the limit. So in that case, we include choose range band. In other words, we essentially go to the top of the passage and start again. No, that choice is no good. Choose another one. If that is okay, if we haven't yet reached the stacking limit, then we just add 1 to enemy underscore hovering Z2. That's what plus plus means. It means add 1 to the current value. Because now there were 2 and we're putting this one in, so it's going to be 3 or, or whatever it might be. You'll remember that we set, once we've finished with this page, we set the distance of this current enemy to be Z2. So that's why we increase that array. And then we look at the else. This is what happens if enemy W4 is not equal to capital Y, in which case it will always be equal to capital N. Those are the only possible 2 values that it can have, given the code that we have. And that means an enemy which is on the ground. And this is exactly the same, except that instead of looking at enemy hovering Z2, we look at enemy ground Z2. And so we say, is that equal to the stacking limit? If so, that's no good. Choose again. If it's not, well, we're going to be adding another ground enemy to that range band. So we're going to increase it by 1. And then we keep going until we've placed all the enemies. And that places the enemies randomly while observing that limit that the viewer wanted of 3 per 3 hovering and 3 non-hovering per range band. And I think that's a somewhat better system than what we had. So it's probably all to the good, even though it does mean that the previous 1 or 2 videos work I've sort of basically gotten rid of, or basically kind of said, no, actually I don't really want to do it that way. So having done that, we're now going to deal with when the enemies move, and because we've got this array, or these 2 arrays, enemy hovering and enemy ground, we don't need to do anything to see how many enemies of a given type are in a given range band. We've already set that up. So we'll be able to refer to these to see whether a given move breaks the stacking limits that we have. So that will make things somewhat easier. But that is something we'll see in future videos. For now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.